Right. Now we get a fun open discussion of using CGI to prepare for HWO. We've already had a few comments about this. I think Bertrand has volunteered to take notes. I don't know, Bertrand, maybe the best thing we could do, you don't want to, you said you don't want people to actually see you take notes, but.
You can take notes in the Teams and team will keep that note.
Yeah, we could do that. I'm not, I could try to type as fast as people talk, but I can't do it. But we'll have the recording of the meeting, right? Okay. So we'll have the recording of the meeting to grab the notes. I think the main purpose of this next discussion is to think a little bit. You've heard for the last 2 days about the advancement and the incredible progress, the TVAC results, and now just about how the planning of the operations and then how the community program is going to work. So when we're looking forward, even more forward towards HWO, we've had heard some ideas of just observations. There's also technology demonstration thoughts. So basically the floor is open as far as I can tell. This is almost in the same spirit of collecting sort of a community input. These aren't white papers or anything like that. Getting to that level. But we'd sure like to hear from this community who's really interested in this results. What your thoughts are, what we could do with CGI to prepare for HWO. Who's going to be a brave? All right, Chris, excellent.
As well. One of the most important things for HWO is understanding PSF subtraction better. So anything that CGI can do to contribute to that would be very helpful. And I just sent Chris an email about this. You have this wonderful tool to model the speckle field, and it seems to be correlated with lab results pretty well. It would be a shame not to do things like model-based PSF subtraction, given that you have put so much effort into those models. So just thinking about alternatives to RDA and ADI that sort of aren't on your plan.
And maybe as part of that, we could have specific targets, like very bright, for which we could get faster temporal sequences. Right. Like Vega would be this one. Just get
how much flexibility is there to stretch out some of those periods and try out or optimize even sort of the stretch between? Can you go back to the reference star and things like that?
I mean, instead of 10 hours every 20 hours or 30.
Yeah.
I mean, you can do what you want. There's nothing there saying it. You have to revisit every 10 hours.
It's a bit of a duty cycle thing, right? I mean,
Yeah.
You don't want to visit so often that you spend half the time.
So, I think Alice answered in the chat earlier that the Roman plans to do a, calibration performance run anyway. That will provide good answer whether our predictions 10 hours stability is good or we're off to the short side, the wrong side. So we'll have to adjust based on what we learn. And also there.
And how often is that that test? If it's a standard test that's like a single block or 2 blocks or something like that, how often is that going?
There's a suite of tests. I think she plans. I don't have the whole length, but we.
Is it 4 days?
Very large, depending on what stars you choose.
Sure, that's fair.
How much is your solar pitch between the stars, and what's your initial solar pitch, and et cetera.
I'll give you a little piece of feedback from, talking about using the near-cam coronagraph to learn for HAB worlds as well. I was pushing on some of these ideas of, let's learn more about PSF subtraction and all that. And the response I got from, some of the telescope team, Space Telescope, was, well, we're not at the point yet where we've, knocked down the other dominant noise sources by pointing errors and other things. And so you what it winds up being is you kind of have to play whack-a-mole with the noise sources to get to the point that you have a low enough noise source that you can do some of these other things. So I think you may not fully be able to predict all your noise sources. I mean, you didn't talk a lot about stray light, but that's always a subtle thing that you maybe have some surprises, things like that. So,
Under the current air budget, that's the largest term, right? The stability term was the largest term, but you're right that if, once you're on Sky, who knows what?
yeah. And with respect to stability, I will say that I didn't hear you talk a lot, because it's chronograph meeting, about what you're gonna learn about the telescope. But, 20, 30 picometer stability telescope, 1 millikelvin control. I think it's gonna be the time constants, really hard to test in a vacuum chamber. They're just doing a simple modulation test. You're gonna be doing a slew, you can watch wavefront. I mean, there's so much model validation you can do at the telescope
Yeah.
observatory level. We should make sure the CPP has a whole team of people just thinking about that.
I think like,
So
the
how much-
lows, sorry, go ahead.
Yeah. How much ability do we have to validate the pieces inside the air budget, piece by piece, not like the end total contracts with the stars, but like. Is there a key or that? Is there a key and blah, 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 blah. How much ability do we have to validate that?
I think that's related to the loads, right? I mean, like, at least on the low order reference sensor side, we can have a look at the starlight coming through the whole system.
Okay.
If we look at bright enough targets, we can do that at pretty high temporal frequencies, and it would be very informative to see exactly how the wavefront is changing. End to end, so you don't know where things are coming from within the system, but you can tell end to end whether that matches the stock models already. You
So-
can see different delta pitch angles, right? That's what they were saying, like from 1 to 15 degrees or whatever, and see if indeed that reproduces what we saw, which was 15 degrees was like way too much. Polarization, polarimetric aberrations we can look at too. So there's a number of.
And in addition to stop models, also jitter models, because jitter will dominate pointing errors. So we
But
can do both.
it raises a question, like, if you have an independent way to measure jitter.
Loads.
Right. Okay. Really useful.
I mean, there's a huge modeling aspect to that as well, right? It's not. If you are going to do something where you roll more than what you've already modeled, then you have to model that whole thing for the observatory. It's going to be- I guess what I want to make sure is, as we talk about different activities here, they're backed up by the models that show that, matching predictions or validating the model.
So exactly right. So what we do in orbit is model validation, but in the meantime, in the next couple of years, we can, for example, communicating with Alice on this, even for the same observance scenarios, the same cadence of rolls and slews, we can allow the reaction wheels move more than plus or minus 5 hertz, right? And there is a trade-off there that you potentially excite in some of the higher frequency primary modes in the structure, but you have fewer zero crossings, which have its own advantages. So we can do some of this initial trades in modeling space, and then use in orbit time to validate the model.
I know something I'm super interested in is after you do like your worst case slew, how that PID control, what the time constants and the wavefront over time looks like with the PID controllers, and how that compares against your models. It's going to be an interesting. That's kind of the equivalent of the way we did it was we did a hot case stable, steady state, and did a cold case at steady state, and then we did a model validation between, not a model validation, but a sort of bounding between those two. In your case, because you're thermally controlled, you don't really have that, but after a slew, you're going to have PID controllers trying to catch up, and it'd be interesting to see what that looks like.
LOFIS line of sight loop is orders of magnitude faster than Roman's reaction wheels can possibly move the observatory. And our FSM is effectively a zero exported force mechanism. It's like the most beautiful thing we've ever made. So I would say we'll recover almost instantaneously from a slew. Once we've done our acquisition process, there'll be very little ring down that's happening after that.
Of the
At
observatory.
least talking about thermal aspects.
Thermal,
Oh, that-
yeah, which are 10 minutes. Yeah.
Do we have an online question from Russ? Russ, go ahead.
Yeah, so what I'll say will echo a lot of what's already been said, but I think kind of generally speaking, we want to try to, well, perhaps prioritize observations on CGI that retire the most risk on habitable worlds or enhance performance on habitable worlds, or some combination of the two. So I don't know if does it make sense to define a working group or a thread that ranks what kinds of tests CGI can do that would most benefit habitable worlds, be it post-processing or some of the contributed modes, or reaction wheel tests, etc. And then plan, by the time it flies, to have a list of prioritized tests that we can do on CGI that most benefit habitable
Sounds
worlds.
like you want to write a white paper, Russ.
I'm not sure, honestly, if I'm the best person to do something like this. I mean, I could suggest a few things for chronographs. I'm also conflicted because I have a contributed mode on Roman, but I'd be happy to be involved.
I think what I was trying to get at a little bit was we certainly don't want to be disruptive to this process that Roman has laid out about how they're going to collect inputs, right? So even if we do have an HWO project team that's working on that part of it, we want to fit in this framework.
Yeah.
Given what Vanessa said about very understandably limited support, ground and human support for the best effort and unsupported modes, I guess what would happen if, and you said you would prioritize the more mature modes. I guess which ones are viewed as more mature in the list?
Well, I mean, things that we call best effort are definitely
Okay.
more mature. AJ spoke earlier yesterday to sort of our level of confidence based on level of similarity to modes that were already tested. I think it was AJ that was saying, well, we've dug a dark hole in an HLC, we've dug a dark hole in an FPC in imaging mode. It's not unreasonable to think then that we would know how to dig dark holes in HLCs and SPCs in other bands. But, Zernike wavefront sensing is totally unlike anything we've tested before. Multi-star wavefront control is totally unlike anything we've tested before. Non-dark hole, very wide field of view coronography is totally unlike anything we've tested before. So I think this is where also, again, the hardware working group comes in with defining maturation plan and gates that proposals might need to go through in simulation hardware so that we can make a more informed decision. That's my perspective.
I think in order to keep this.
Okay, so something that strikes me in these conversations is there's gonna be a balance, given that we're gonna have competing time out of a very fixed slice of pie. Because a lot of these things we're talking about, the point of model correlation or model validation are not gonna be things that are gonna get us the best contrast on the best targets, on the deepest things we can do, but they're still gonna be very time consuming. In fact, a lot of the things we were just talking about are gonna give us pretty bad contrast results. We were looking at that, like messing with the reaction wheel speeds, for example, trying to go through ranges of jitter and thermal environments that are gonna give us these worst case scenarios.
So one thought there is that, something that winds up happening is you start with this extreme case that's time consuming, then you realize I can get 90% of what I want with stuff I'm already doing. Well, I'll do this slew. Maybe it's not the worst case slew, but it's still a pretty large slew. And if I insert a little bit of a wavefront, 1 hour wavefront, I get that stability. So you might look to leverage things you're already doing to get more information out of it.
Totally.
You can read the reaction wheel speeds, send them to the ground and you say, okay, this.
I was gonna say, and the problem that Julie brought up of the 4-day cadence for the supernova or the high latitude time domain survey, maybe that's a benefit, right? We're slewing a lot from the sky back and forth. So maybe those are opportune times to run horror scenarios because we're not going to be.
Well, speaking of that, I mean, even while the well field is on, is there capability just sensing things?
Wide field has, wavefront control sensing capabilities. Different time, and I'm pretty sure the wide field camera by a bunch of data. Maybe Matt can make some comment. Have us, understand better how the telescope.
Yeah, I mean, they wanted to do it to calibrate the telescope.
Yeah.
I've talked to you about this.
What state
Which would benefit us from a telescope stability understanding.
Yeah,
We do multi-field phase retrieval. And then that seems.
That's super slow.
Yeah, that's really slow and very infrequent, and
Yeah.
it gives you a snapshot of a single point in time, and that's all you're gonna get from that.
I mean, it's super slow.
I mean, it takes hours to collect a phase retrieval data set.
You gotta move a secondary mirror or something.
Well, so there is a faster mode using the focus drives on the SM, but that's not that's not a baseline operation.
Yeah.
And B, it doesn't give you as much
But-
defocus, so,
Yeah,
but even that is still,
but when you're doing a relative phase retrieval measurement, you don't need diversity. You could do it relative to your starting point. This was what Alden did.
yeah.
So you could do that. We did it. We took data every 8 seconds. Got down to 100 picometer on JVST, which was surprisingly good resolution. Like in a relative, in a resolution sense, relative phase retrieval, you can get really well.
So I think something like that during commissioning is possible. I think something like that regularly or even a couple times during the science, we'd have to look at whether it's gonna have an impact or not.
I'm curious, we have to realign and refocus as the structure shrinks. So we are, at least the first year, we'll be doing a
Yeah,
bit of that.
but that's not interleaved with sleeves.
And just one comment directly related to that. The other thing that we needed to remember is any of that stuff, like even if we try to do, which by the way, we did use a lot of this single image phase retrieval stuff in TVAC too for wide field. We tested literally over 200 field points as a result, which is kind of amazing. But doing that on orbit, you have to be able to also still guide with wide field, do anything CGI, right? So asking it to be our guider and our wavefront sensor is something at the same exact time is something we need to think about if we want to try to do something like that. Very good idea, but
Well, I think
not a home run.
right, but what we're saying is you want to understand the telescope
Yeah.
model.
Yeah.
You don't need CGI. You can do that with WFI after the flu, looking over field, and you can even get secondary mirror stability, and then you separate that from, so.
I mean, two questions I have about, what is the CGI state? Wide field cameras. Are you guys, so especially in the days where you have like one day where you're gonna be not taking data and the possibility of taking data again later, do you have anything on just maintenance, stability wise, housekeeping data? What do you guys?
Yeah, electronics are for sure.
Okay.
And that's important to that annealing process mitigates the radiation damage that we're already concerned about.
Yeah, in the EMS, we keep them at the same voltage, we don't touch. We keep the voltage for the next observation.
The other thing is that kilohertz, low order wavefront sensing. We didn't have anything like, we would have loved a kilohertz in JW, so that's be super interesting, because now you're gonna see every dynamic mode of the full observatory. You'll see modes changing with time. I mean, that's gonna be hugely.
You would want to really fast, but it's really noisy the way we actually want to operate CGI. So we would have to allocate time for CGI to look at an unusually bright source just to measure the dynamics of the observatory, which is not off the table, but it's not like day in the life of regular CGI.
So that will benefit that'll benefit the dark energy, science as well, right up front, because then you'll know after a SLU, my secondary mirror is doing this for 30 seconds. So I need to wait a little longer before I take science. So that kind of stuff would be a smart early commissioning.
We've got Carl online.
Yeah, can you hear
Thoughts?
me?
Yep, we sure can.
Yeah, I like all this discussion of potential experiment ideas to conduct with the instrument. So I have a CPP hat that I wear, and I'm also on the observation planning working group. And I just want all the HWO folks to know that we really are going to pull on you guys this fall to give us your ideas about experiments that might be conducted on orbit, along with we'll do the same thing for the SAT, HCIT folks, and maybe it's something a little less technical with the astro community. But there are reasons to want to do that this fall. And so I hope that you guys can, like John referred to earlier, set up your own little internal process to produce some recommendations and package them all up using a template we will eventually send you. So we look forward to you guys really digging in on that this fall if you can find some time in a subcommittee to do it.
Thanks, Carl. Other idea? Please.
Emphasize something that Eric mentioned yesterday, that certainly on our minds from CGI TVAC experience, but also will be very important for HWO. So the requirements, I understand the process for setting HWO requirements is still, in work, but people talk about 1 × 10⁻⁻10 contrast. So when you're far away, it all seems roughly the same, but when when you need to meet it, right, this distinction between, let's say, 1 × 10⁻10 coherent versus 5 × 10⁻10 incoherent can be just a life and death situation. And it's certainly just different between failing and meeting it. And as you have seen on Brian's talks, the way these two components propagate through their budgets is very different. They're much more sensitive to coherent than to incoherent. But in order to set this requirement, relax the requirement on coherent, you need to believe in your incoherent estimate. And we've run into some issues, on CGI because, incoherent technically shouldn't reduce, but it went down. I don't think it's a CGI issue. I think it's overall state of coronography issue. But, and for us, it was okay because we said, well, we can meet it in the most conservative way, just bring the total below the tightest requirements and you're good. But I'm not sure that HWO will have this luxury. So people in the community investing more time in understanding coherent and incoherent to the point that we believe the split will allow us to set requirements for HWO that we can meet.
I'll just say, if I can make a comment on that, I think the question is, because I think a great place to evaluate that is an attestment. But then the question is there something you'd want to do with CGI?
Yep. Exactly.
Yeah, because
Like, for example, now you have a different resources in a artificial.
exactly, that's the big thing. And
You
that's
actually
one
have
of
a
the
real
only
source.
things that make it easier on Sky is to make a real point source. And this is difficult in the lab.
Yeah.
So Marie had a good comment earlier on about being told that she couldn't use JWST as a sandbox for doing weird experiments. And so I think we're going to have to confront that with Roman as well, if we want to do some of the things that we've been talking about in this room. That we'll have to have an exception that allows us to do something that is really only for learning about coronagraph performance.
It sounds like it. Charlie, do you mean at the observatory level or in the coronagraph? The coronagraph, it sounds like the CPP is going to take that into account, like it's already built into the idea that, I don't want to call it weird, but there will be, things that are specifically for demonstrating technology.
I could imagine if we're talking about using the WFI to learn.
Yeah, exactly. So if you're talking about, rolling more or slewing faster.
But she was talking about things that are at the level of, let's take over the observatory and run some experiment on wide field and coronagraph at the same time, so that we can learn about, this thing that we haven't puzzled out yet.
Yeah, so if I may, I was specifically addressing the reaction wheel speed changes that we were asking to calibrate our jitter models, which we never really got to do. And then at one point we wanted to do the cryocooler tuning, which involved changing the slight changes to the cryocooler frequencies by, tenths of a hertz, plus or minus, and we were told no. If something works, they don't want to take the risk.
Kelvin on a detector, we were not messing with our coolers.
But anyway, I think fair enough, right? I mean, I think if we, if we are gonna come up with a group inside of HWO that starts listing these things down, there's certainly a category of observatory level things that we can also inquire about, I would say. But it's the mechanism that, I'd say within this framework, we want to stay within this framework primarily. And then if there's things outside of this framework, maybe we can.
There's a last filter, the Roman project decides at the end.
Yeah. Okay, we have Nick Siegler on too. Thanks to Vanessa for pointing out all the folks online. We're actually working.
Yeah, John, I think one of the most interesting masks that we contributed a couple of years ago to Roman is the Zernike wavefront sensor dimple. So thanks to Feng and his team, they actually put in the hybrid Leo substrate several dimples that can be used. We funded it, so CGI didn't have to search for funds. But I just wanted to remind the group that probably is a good shot maybe to appear on a Haberl's design. And so if we want to demonstrate that in space, that would obviously mitigate the risk involved with that. It's just that we never funded the flight software to execute that. So just keep that in mind, that if that does bubble, close to the top of the Have World's desired list, that we'd have to come up with some funding for that.
Thanks, Nick.
And
I'd like
one,
add, I wanted to a point that Ilya made earlier, which is about the luxury of things that we didn't do. Luxury to not do things. I think we really need to pay attention not just to what CGI did, but what CGI did not do. Because if we're going to follow up CGI with habitable worlds where we're targeting, 2 orders of magnitude better, people need to know that CGI deprecated contrast stability to analysis instead of test. And we had a 54-day TVAC. We didn't test contrast stability. We don't have spare hardware on most of our critical assemblies. We didn't do 2 TVAC tests. It still cost $450 million. And we still took a real long time. And we're still at an institution that is in deep trouble because a different project didn't pass KDP-B for cost. So we need to, at the very least, condition everyone now to understand that Have Worlds is going to cost a lot of money if we do it the way that we want to do it. And we need to point to the things that CGI got away with because we're Class T.
I view it as an opportunity to use the existing CGI, right, that has a funding stream and if we show how important it is, there's opportunities there maybe, but hear what you're saying.
Be surprised how much any instrument on flagship costs. CGI wasn't cheap, but fly a camera.
Well, I mean, again, Lee said it before, it's a huge investment, right? And so we've got to take advantage.
Like, just on the DMs, the amount of frustration that I received when I would tell people that we have no telemetry on the DM other than a couple thermal sensors. And it was like, well, we have 2,400 electrical channels. We're going to have 9,000 or something of them for if we go with a 96 by 96 DMs. Just continue.
Multiply by 8.
Multiply by 8, sorry, yes. Continuing with things like that when we consider what our risk postures are for Have Worlds. How much those would balloon.
You even had a discussion over lunch, if we're going to be talking about that CGI made a conscious decision to limit it to 10 hours for stability because that's something that, you can model, you can test and have those things. We've had the same debate on LISA, whether we go down to all the way down to 0.001 millihertz. And the idea was, no, that'll be so expensive in INT to verify all those requirements. That's a goal. There's no reason why we can't model that, but not going to require.
So I have to follow up on what you said. I have to say I'm delighted at the level of technical detail we're all struggling with. The reason I say that is that 11 years ago today, we were meeting up the road in some basement conference room and trying to decide if we could even build a coronagraph. And I'll remind you, at that point in time, no circular hybrid Leo masks had ever been fabricated. They were only linear. No one had ever designed a shaped pupil mask, to my knowledge, for a obstructed pupil. I don't think the mathematical techniques were only just being invented. No one had a CCD that would stand up to charge transfer inefficiency, and you all have invented that. I mean, we've come an incredibly long way. I'm sure I've left out more than half of really critical advancements that have been made in the last 11 years. So when I see how far we've come, you guys will figure out the Have World stuff. I have no doubt.
Thanks, Jim. Remember, 11 years.
That was inspiring.
Without knowing whether it could be done or not.
Young to be so
Yeah, it always seems scary.
I'll say great while you do it.
I think that deserves a round of applause. That 11 years.
And we should probably say the Have Worlds team wants to thank themselves. Got those interconnects working. I have to say, the thing I was most worried about were those interconnects. I thought you guys had a 50-50 shot of getting that to work at your key SRR or something. But if you guys weren't successful, I'm not sure that the Have Worlds team would be here right now. So thank you all. Well, yeah.
Right, any other questions, comments, thoughts, closing remarks? Anyone? I'm gonna sit down.
Closing remarks is already a big thank you to Marissa. In the workshop, all you have to do is send an email to Marissa, tell her the date, the location, and then everything appears magically. So, thank you, Marissa. We would like to keep her though. And then, thank you everybody for making it through these 2 days. Hopefully that was useful to everyone. We are really excited with what happened with CGI. I think I want to thank also Bang, Ilya, Vanessa, and Patrick also for putting together the program for these 2 days. That was enjoyable to you all. For CGI itself, for the future of CGI, and World HW in 11 years or less or more. All right, thank you everyone.
And maybe just also thanks to IPAC for
Thanks,
hosting us and providing especially an ability for people online to hear conversations in the room. Yes, it's particular.
Yeah, thanks for our hard work. And also, the information on the website.